Hi, yeah, I'm Tom. I'm a new Futurist member. I've just got off onboarding camp, so I was excited to present to you guys here today. So my background, I joined a plucky startup, Firebase, in 2014. We got acquired by Google, and then I worked for 4 years at Google, and now here I am. I moved back to Europe. I'm originally British. I'm in the Berlin office. Um, and so I thought, while it's all still fresh in my brain, I'd give a quick sort of overview of like how services are built, like technically how they are built at Google. Not necessarily it's like this is the right way, but it's interesting to see why they built things this way. And so this talk is gRPC service design. And I want to talk about like lots of things very broadly. What is gRPC? Uh, how are APIs designed and why like a lot of energy is spent on designing them correctly. Some common deployment patterns, how you actually, deploy the services to implement the API to provide the service, and then how over time things are incrementally developed, because that's an important part of the design, is that they're designed for incremental improvement. And so the thing driving everything is that APIs are long-lived. They outlive the implementation usually. So API transcends like an argument on whether you should use Java or Python, because to Google it doesn't matter. You can swap out the implementation at any point. The thing that stays for a long time is the API. So all the design effort is mainly spent on getting a nice API definition. And some general rules that are followed is like have a few very general purpose RPC endpoints over having millions of specialized endpoints, because that's a maintenance burden. You want your microservices to be reusable. So therefore you want a few very general endpoints over lots of specialized ones. Another thing they do is they avoid passing around top-level domain objects. Sometimes with a REST API, you want to return like person, but the way they follow is they always return a person response, and inside that person response is the person. And that level of indirection at the top-level RPC is because you can upgrade the system better by manipulating that response object, while the domain object is, kept cleanly from the sort of serving infrastructure. And it's very easy to add fields to a schema, to an API, but it's almost impossible to remove or rename them. And that's another reason why you have them at these things at the top level. So because APIs are long-lived, never commit in the API to features that are going to be difficult to maintain long-term. So always start with a stupidly simple API and only add features if absolutely necessary, and after you've pushed back and said we can't do it umpteen times, you go, okay, we'll do it. All this stuff is public. This happened, I mean, I've only been at Futurist a month, but the one client I'm working with, they're already like totally down on resource-orientated design. So if you're interested in that, like the Google Cloud API design guide is public. That's a good resource. It's all about resource-orientated design, which includes like, this is about gRPC. gRPC maps to REST as well. So you can learn a lot about REST design just through these design documents. And if you want to see examples as well, like all the Google Cloud APIs, all the Maps APIs, these are all public documents. So you can just look at like how they did it. If you like, don't try and do anything from scratch, just copy something else. That's how we worked. So why do they use gRPC? gRPC, that's like here's some endpoints and they pass around protocol buffers. Protocol buffers are a serialization format, like a type thing. Here's a message, it has a string for a name, a number for age or whatever. So these messages are typed, and there's a way of converting them to and from a binary representation. gRPC then wraps protocol buffers into, this is how you do a call over a distributed system. And they're designed for forwards and backwards compatibility on the serialization forward. This is all part of like, you've got to design for this thing to be incrementally improved. And you can store them onto a hard disk and then get them back 10 years later and it won't crash the system because they're designed to be resistant to that. So they're also very efficiently packed. So at Google scale, they want to save, resources by doing it efficiently, unlike maybe JSON is not the most efficient. gRPC handles all the common performance optimizations like pipelining, batching. That's all built in there, and you don't have to corrupt your API with thinking about batch requests. And we spend a lot of time coming up with these protocol buffer definitions, the service definition. That becomes the source of truth driving everything. So the REST API is generated from that. All the clients are generated from that. Even the reference documentation is generated from that. So, equivalent things are like GraphQL, Swagger. It's that kind of thing. So this is what it looks like. I've got a service called the Welcomer. It has one RPC endpoint called say hello. It takes a hello request and returns a hello response. Here's how I map it onto a URL. And this hello request is a type thing. It takes just a string payload of a greeting. And then from that service definition, you can generate, for example, a TypeScript client. And this TypeScript client is, properly typed. So it's like I create a new welcomer client, blah, blah, blah. And so because it's typed, it's, you've got IntelliSense and stuff. It's not just for request response. You can do streaming, server-side streams, full duplex streaming, just client streaming, any combination. So that's gRPC, designed for forwards and backwards compatibility. So how do you deploy these things? So a common pattern I've seen is the control plane, data plane separation. So you want like information to flow in only one direction, and the reason why we separate control plane and data plane is two different users tend to interact with these systems. There's like the developer. I'm an App Engine user. I upload a new App Engine project, so they talk to the control plane. But then at some point, a user requests my web page, and I spin up an App Engine instance and serve that request. And so there's like these end users, and they're interacting with the data plane. And these two things are scaled independently. They might not be in the same data center. But the idea of the control plane, data plane is that there's a unidirectional flow through some kind of like shared storage. And that's like the pattern. And there's different reliability. This is like, we must never go down because a business is losing. But the control plane, that can go down sometimes because it just means people can't update their apps. They're annoyed, but it's not business critical. So different data centers, different reliability. That's why they're separated. When you come to implementing these things, the thing you're thinking about, especially for the data plane, minimize, third-party services, external dependencies on your critical path, and pick reliable dependencies. Do read like the SLAs, SLOs, because products have wildly different reliability. And the general principle is you make the system as simple as possible and use as few dependencies as possible. Try and be stateless. Avoid too much like error handling within the service. Try and push it to the user and make your clients clever. That's like the ideal. And so for an example of like one shared storage you could use is like, when someone changes the settings of the service, we'll write to a cloud storage file, because cloud storage is like super reliable. We'll write into a file bucket, and when a data plane task gets a request, it will just, have I got it cached already? Yes or no? No, okay, I'll go to cloud storage and fetch it. Otherwise, I'll just serve the one I've already got. And because we want data to be unidirectional, in order for us to get updates, we'll just let this one naturally fall out the cache. So just have a fixed cache eviction policy. So eventually, it's a bit laggy, but the data planes will always eventually converge to the latest, version that's the control planes published. And the reason why we keep these unidirectionals is you don't want this service to know the address of this service, because the data plane is generally going to be larger, and you want to spin up new control plane tasks in different data centers. So it's good to, it's difficult when this one has to know the address of this one. By keeping it in that one direction, it's easy to spin up new clusters without having to, update some global record of where everything is. So that's why generally you avoid these bidirectional links. But this is a bit shitty because there's like a 5-minute cache eviction. So people start complaining that they're updating their service, but it takes a little while before it takes effect. So this would be like alpha quality. And then we want to upgrade as we go, and we don't want to impact our reliability. So an example of this would be, okay, so now the control plane, it does what it did before, which is write to the cloud storage, and the data plane, is driven by its cache eviction policy. But we'll add in this extra completely parallel data flow, which is we'll write a message to pub sub, and then the pub sub, these data plane tasks listen to pub sub, and when they see a message that something's it's been updated, we'll just invalidate our cache. And that way, although we've got another dependency on pub sub, it's not on the critical path. If pub sub goes down, the system works how it used to work. So that's how you maintain reliability. You upgrade by adding sort of parallel flows of data flows. The next thing you might want to do is let's upgrade the reliability even more. So you can put a global load balancer over the top. You have multiple data centers. So we've got a data plane in, region A, region B, and that works out. That works out really well if you're using cloud storage because that's already geo-replicated. So the simpler the system is, usually the easier it is to geo-replicate it. And that would be, that last push for reliability, that will take you from a beta product to a general availability product. There's other things you need to consider. Like most services, they also have these common things like you need to bill for it, you need rate limiting for it. These are common problems that all services have. So that's why they have this technology, a service proxy, which just sits in front of everything and does all this kind of accounting on behalf of your service. So that's publicly available as service proxy, I think, in Google Cloud. But, this is also done by Envoy, like in the public domain. Authentication, logging, and metrics, these are like common things. Yeah, so, to sum it up, control plane, data plane separation, that's like a natural delimiter, and it's worth thinking about like this endpoint, is it control plane, is it data plane? Dependencies have a huge impact on overall service reliability. So you keep it simple, minimize your critical dependencies, but by all means add optional dependencies. Just don't put them on the critical path. Read the SLAs, and you can productionize a service incrementally. So you want to release early with a really sort of crappy thing. So it's in the hands of your customers early, and then you can build these things up over time into like super bulletproof services, but that, maybe that takes 2 years, but you can get it in the hands much earlier. Any questions?
Okay, I'll ask you a question. So how does this play out in like a node strict TypeScript API setup? Is this something that could be integrated with that?
Yeah, protocol buffer, like client generators are available in literally every language, PHP, Unity, C#, everything. So TypeScript, it works really well because, it's typed. JavaScript, not so well, but it will produce a client. It just, you can't type check it. But yeah, it all works with that. gRPC was originally designed for more server-to-server communications, and then because like mobile, it worked really well on mobile as well because you had like native generators. Where it was slowest to come to was the web. So gRPC for web was like a much later technology, but they've got that working as well now. So yeah, it works across all platforms, all situations pretty much.
Okay, are there any final words of wisdom, or like if there was like one key takeaway, what should we take away from this talk?
Yeah, so just because in my few client interactions here at Futurist, like the client asks for a resource-orientated API design, that is the most important thing, is make your API really good because it's really hard to change later, version it, make it really good, and if you want to learn more about good API design, like Google API design docs, ignore the gRPC bit if you're not interested, but it still covers what is a resource-oriented API, and that is very valuable. Like, get on a collection, patch on an entity. All that thing's explained in lovely detail. And I actually gave it to the client, and he's using that design doc now. So that's like gold standard of resource-orientated API design. Very valuable.
Okay, so I think that's it for today. Thanks, Tom. Thank you, everyone, for coming to Tech Weeklies.